Hey guys, hi everyone, welcome back to Vlogs with Sanchara. Today we are going to learn about mapping between rotated frames. This is the topic, mapping between rotated frames. This diagram which is here, I have written it in a bigger way and I'm going to show it to you. So this is the diagram which is given over there. So first what is happening, we have this X, Y and Z part. Okay, this is our axis X, Y and Z. What we are doing, we are rotating it. So I'm rotating it like this. This X is going here, X is like this, it is going to U, Y is going to V, Z is going to W. So this is how the rotation is happening. In this direction, the rotation is happening. You can even mark this to show it in a clear way the rotation is happening. After drawing this, first write off, this part is Px and this U is there, so this is Pu, Py. And here one more thing guys, for point P we are finding, this is the main point of us. Okay, for this main point we are finding things. This is frame 1, or you can also denote it as X, Y, Z. Okay, instead of writing frame 1 you can write 1 also. This denotes frame 1. Okay, 3 types are there. This is frame 2, no, this W. This is 2 or U, V, W. Okay, so what is happening? This is frame 1, it is rotated and it became frame 2. Understood? No. Now how these lines and all came, I'm going to say you. Okay, first what you do, Px and Py we are going to join. When you join Px and Py from O point you're finding, no? So put a line like this. Okay, after this what you're doing, from O put a line between Y and U. Here between X, after X and V you have put, no? Between Y and U you put a line. After putting, join this with Y. Okay, next this P point which is there, no, join it to W and Z. This Z point should be connected to this U and Y, no, so connect it like this. This is the orientation. Okay, after this we have to now prove what is happening between frame 1 and frame 2, what is inverse, what is translation, what is rotation matrix and all we are going to find. Rotation matrix is very important. That is what you're going to find here. See, origin is same for 2 frames, right? This is the key point, important point. Origin is same for 2 frames. For both the frames, origin will be same. Okay, you're just changing the position is changing, orientation is same. Okay, now come here, let me explain. Here the first thing you have to note down is what is frame 1 coordinates. 1p is nothing but 1p x cap plus 1p y cap plus 1p z cap. How did this come? See, this is the frame 1. No, for this I'm writing 1p denotation. I'm writing what is there, px is there, py is there, pz is there. Okay, with this we want, these are called as unit vectors. Unit vectors are must in this thing. So 1p will be 1p x cap plus 1p y cap plus 1p z cap. Similarly, 2p will be 2p u cap plus 2p v cap plus 2p w cap. Okay, this is the first thing that you have to know. After that, what I've done, description of point P in frame 1 is known as description in frame 1. Description of point P in frame 2 is known as description in frame 1. Okay, that means that whatever in frame 2 is there, no, that is happening because of frame 1. That origin only is rotated. Okay, so now we'll write equations. What is 1px? 1px is x cap into 2p. Why is it x cap into 2p in the sense? See, 1px you're finding, what is this 2p? Whatever rotation is happening, that is the 2p thing. So it is nothing but unit vectors of this first thing, that is x cap, y cap, z cap, into 2p, into dot products of second frame. For the first frame if you want to do, the answer for that will be unit vectors into dot product of second frame. So x cap will be like that only. You have the expansion for 2p, right? This is the expansion for 2p. Substitute that here. Okay, you'll get 3 things. Now this thing will write it in a matrix form. When you write it in a matrix form, 1px, 1py, 1pz will be like that only. Here what you're doing, see, x cap, u cap, x cap, v cap, x cap, w cap is same in all the things, right? Here also, y cap, u cap, y cap, v cap, y cap, w cap, z cap, u cap, z cap, v cap, z cap, w cap. It is there, no? So now this thing you separate it. Rest what is there? 2p, 2p, 2p. Okay, that is 2px, 2py, 2pz. Why 2px, 2py, 2pz? Here you have separated it. Here you have 2pu, 2pv, 2pw. All this you have separated, right? Rest is whatever you have here, 2p's, you're going to write that here. Done. This is the matrix form. After this compression matrix, we're going to write 1px, 1py, 1pz. What is that here? I've said, you know, but 1p. So 1p is written here. This is your rotation matrix. Dot products of 2 frames. Dot products of both the frames is called as rotation matrix. So x cap, u cap, x cap, v cap, x cap, w cap, y cap, u cap, y cap, v cap, y cap, w cap, z cap, u cap, z cap, v cap, z cap, w cap. Dot products of frame 1 and frame 2. This is the easy way to remember. Dot product of frame 1 and frame 2 gives your rotation matrix. Okay, see, here I've written 1r2. Why 1r2? From frame 1 it is rotated to frame 2 into whatever is there here, 2px, 2py, 2pz. That is nothing but 2p. Okay, next what we're going to do is 1r2's expansion I've written. Okay, because frame 1 and 2 have same origin, they can be rotated with respect to each other. R is rotation matrix, therefore R is rotation matrix. Okay, if they had different origins, then orientation would change. Now only position is changing. Rotation means position change, translation means orientation change. Remember this. Okay, next, it contains dot product of unit vectors of 2 frames and it is independent with point P. Why is it independent with point P? Here we have separated, right? So it is independent with point P, and there's no P point is not there anywhere. No, so it is independent of point P. On similar lines, 2r1 can be obtained. 2r1 is what? Just translation of this. Rows rows will become columns, columns will become rows. That is what I've done here. So next what we'll write, this 2r1, 2p is equals to 2r1 into 1p. Here before one what we had, 1p is equals to 1r1 2p. So for 2p it will be 2r1 1p. Okay, that says what? 2r1 is nothing but translation of 1r2. This translation is only this. So 2r1 is nothing but translation of 1r2. Now coming to equation. This is equation 1. Okay, this is equation 2. This is equation 3. From equation 1, 2 and 3 we can say 2p is nothing but 1r2's inverse. Okay, that is simply 2r1 is equals to 1r2's inverse. That is nothing but 1r2 transpose. I said, 2r1 is nothing but 1r2 transpose. This is the final conclusion that you will have to remember. That is all is about rotation. In next video, I'll explain about translation. Thanks for watching.